And it looks like Chris is back with a working laptop, and so we'll let Chris Voiton will take it away and talk to us.
All right. Thank you very much. Thanks everybody for coming out. It's really an honor to be here. So some of my favorite award talks in the past discussed inspiration or how to choose which problems to work on. So I'm going to talk about one of my motivations to work on problems in computer graphics. A while ago, I came across an interesting passage from the Princeton Companion to Mathematics. The book briefly talks about the cultural differences between mathematicians and physicists. And it says, mathematicians are far more interested in finding rigorous proofs, whereas physicists who use mathematics as a tool are usually happy with a convincing argument for the truth of a mathematical statement, even if that argument is not actually a proof. So the result is that physicists operating under less stringent constraints often discover fascinating mathematical phenomena long before mathematicians do. Now, I thought this concept was really interesting because the argument hinges on these less stringent constraints. It implies that a stubborn insistence on correctness actually slows down progress. By loosening these constraints, taking risks, and acting on intuition, it's possible to make huge leaps forward, although you also risk making huge mistakes. So I think that we can look at computer graphics research in a similar way. While mathematicians value rigor and physicists value accuracy, we value different concepts like efficiency, robustness, and visual plausibility. We're not constrained in the same way as the other fields, and we can take huge risks by simplifying a problem way past what a mathematician or physicist would feel comfortable with. We can even throw away parts of a problem that seem to be too expensive to compute, or we can replace difficult pieces with something simpler. And if we're lucky, our unique approach to these problems might actually give us deeper insights than we expected. For example, we can look at Craig Reynolds' research on flocking from 1987. So Craig showed that a very simple set of rules is enough to reproduce visually plausible flocking motions similar to the way that animals and humans behave in groups. Nowadays, this work has over 10,000 citations, and it's routinely cited as a fundamental starting point in biological research on behavioral dynamics. So my work is nowhere near as influential as Craig's, but I'd still like to share some examples of how some of our computer graphics research led to bigger questions than we expected. So I'll first talk about some of the work we did on liquid surfaces. In computer graphics, we often try to speed things up by making the liquid surface more detailed than the physics. Unfortunately, this can violate physical rules that require certain vectors to line up exactly. So if this angle is not exactly 180 degrees, then something is definitely wrong. When the vectors don't line up, it can create creepy, unnatural behaviors like this liquid that doesn't know how to flatten out its own surface. So in 2013, Morton, Boyce, and Hansen came up with a way to correct these mistakes by rotating the surface normal into the right alignment. And this correction can be used to smooth the surface, like the video on the left, or it could be used to turn the mistakes into liquid waves, like the video on the right. Afterward, Ryan Goldade made this method faster so it could work for much larger scale simulations. We also found that our update rule is eerily similar to the vortex sheet equation, which describes the motions of real liquids. Now, I have no idea why there should be a connection between the laws of nature and a trick for fixing the hacks we do in computer graphics production. And I'd love to know if this is just a coincidence or if there's a deeper connection here. So we also spent a lot of time thinking about how water interacts with air. So one of the most important concepts when studying the interactions between two fluids is called the Atwood number. And this number basically describes how much denser one fluid is than the other. When the fluids are almost the same density, then the Atwood number is really close to 0. And when this is true, you can make all kinds of simplifications, and the simulations are generally well behaved. On the other hand, when one fluid is much heavier than the other, then the Atwood number is close to 0. The Atwood number is really close to 1. So these situations are much more frustrating to simulate. and one fluid completely dominates the other, and the simulations divide by 0 and blow up. Unfortunately, the Atwood number for air and water is 0.998, which is dangerously close to water. It's dangerously close to 1. So while we actually need to simulate water when we're doing computer animation, so what can we do about this? The common workaround is to ignore the air phase altogether. Sadly, this approach causes air bubbles to collapse around themselves, and it removes all the interesting two-way interactions as well. This might be okay for some animations, but it's unacceptable for sound simulations or for physics where the bubble dynamics are actually really important. So in 2015, Ruichi Ando discovered a way to simulate an Atwood number exactly equal to 1, which, while it still preserves all the constraints like mass preservation of the air bubbles rising up in this hourglass animation. So this simulation remains stable, and the math cancels out so elegantly that the air phase doesn't need to be computed at all. This surprising cancellation raises a lot more questions for me about the physical nature of multi-phase flows. Like, why should the air's volume preservation be essential, yet the actual particular air velocities are totally irrelevant? Hopefully, tools like this can help physicists and mathematicians better understand these complicated flows. So aside from fluids, we've done some work in geometry processing as well. So during shape modeling, we often might want to add or subtract pieces from a shape. So we might want to take a cylinder and subtract it from the shape of the zombie. Usually this results in a cryptic error message complaining about Boolean operations and manifolds. The problem here is that while there is a rock-solid theory of constructive solid geometry for perfectly clean shapes that are closed and oriented and manifold, there is no existing mathematical theory for computing topological changes with messy shapes that have holes or inconsistent orientations or self-intersections. In 2013, Gilbert Bernstein came up with the first step towards a practical algorithm for computing topology changes for arbitrary surfaces. As far as I can tell, mathematicians have never even asked this question before, and I think it's really exciting to think that there's such a wide open frontier for new ideas. So what if computer graphics researchers discover the fault-tolerant theory of constructive solid geometry before any other field? We've also recently looked into some fracture simulation work. So for fracture, the surfaces that result from objects breaking apart have all sorts of interesting qualitative details that have been extensively cataloged by geologists. So they exhibit roughness variations, they exhibit sharp intersections where crack fronts collide, and they have these chevron patterns that indicate the direction of the crack propagation. So these surfaces are extremely detailed, and they're extremely difficult to simulate accurately. Last year, David Hahn developed a physically based fracture algorithm that emphasizes visual detail and it prioritizes it over an accurate simulation, an accurate solution. But our simulations still reproduce these detailed surface patterns that are difficult or impossible to simulate in any other way. We still don't know the definitive causes for these qualitative fracture surface features that get geologists so excited, but it looks like the underlying process might be a lot simpler to model than people realized before, and that's exciting to me. And it's also just really fun to watch bunny rabbits shatter into pieces. Finally, I'll show you some of our recent work on thin liquid sheets. Fang Da had this idea to abandon an accurate volumetric simulation in favor of a method that only uses boundaries to simulate liquid motions. So this reduction in degrees of freedom sacrifices a lot of power, and we can no longer simulate everything that we need to do that we could when we had the whole volume. However, despite these simplifications, the method is still able to reproduce qualitative effects like fluid chains, and it can also convincingly reproduce the instability of thin sheets. A similar approach is even able to simulate extremely complicated dynamic foam behaviors without the need for extremely powerful computers. We were able to reproduce complex phenomena that is observable in nature, despite the fact that we intentionally cut out loads of properties, like viscosity and finite fluid densities. These fluid phenomena are still not that well studied outside of computer graphics, and perhaps simulation tools like Fang's will be the key to learning more about them. So those were 5 quick examples from my work that started with standard goals of computer graphics, like efficiency, robustness, and visual plausibility, but they led to more fundamental questions later. So if we return to this quote, physicists are able to discover ideas more rapidly than mathematicians because they don't have to be as rigorous. But I'd like to argue that the main idea of having less stringent constraints applies even more so to computer graphics research, because we have far more constraints that we have to worry about, or far fewer constraints that we have to worry about. So I'll rewrite an analogous statement about computer graphics. Computer graphics researchers operating under less stringent constraints can discover fascinating mathematical phenomena long before researchers in any other field. But it only works if we exploit our advantage of less stringent constraints. In other words, it only works if we take risks and if we embrace novelty. So I encourage everyone to please continue being so creative, because it's one of the things that makes our community so amazing. Thank you very much for your attention, and I'm honored to have this opportunity.
Any questions?
All right. Thanks.
So I'll just make one comment on the last few talks. And it's one of the wonderful things about computer graphics. We all, or many of us, came into this field to try to understand how the world works, why the world looks the way it does, and operates in the way we see things. In the end, we really want to be creative as well and just get things done. And this intersection has just really been a driving force. I really appreciated that talk. I really loved the talks before as well. With that, I'm going to relinquish the floor. I'm going to turn it over to Terrence Masson, who's going to introduce our Outstanding Service Awardee. And stay tuned after that for a wonderful video about Steina.
Hi, everyone. I'm only going to take just a few seconds to leave all the time to Elaine to emphasize the importance of volunteerism. So in a quick repeat of what I said earlier this morning, I don't think it's commonly known how much volunteerism it takes to put on the conference and run the organization. When I was conference chair in 2010, we ran some numbers, and it seems that it requires more than 70,000 men and women volunteer hours to put on a single conference of 5 days. And a lot of those hours are accumulated year after year by individuals, single individuals. Elaine is a great example who's been doing this for more than 30 years and is part of a 3 generation of his family of volunteerism. So without further ado, I want to turn it over to Elaine and thank him for his contribution, and look forward to hearing what he has to say. Elaine.
Okay, put him up here, and, okay, he's sliding. Here we go, a little bit of physics here. You want to help us out? Okay, so let me go back to the title slide, which we weren't on before. Okay, so I'm going to go and expand a little bit on what Terrence just said. One of the interesting things about the Outstanding Service Award is that it does recognize volunteers in their role. And I'd like to point out all of the elements involved in volunteerism and how that actually applies to Siggraph so that you can see what this actually means, and want to give you a couple of examples. So when we talk about volunteers, I'd rather talk about volunteer spirit, because Siggraph has a very, very interesting dynamic in that even our contractors, the people who are paid to go and do the work, act like volunteers, act with the passion that we see from the people who just donate their time. Our key people who organize our conferences, who make all the activities that make Siggraph so interesting happen, are people who give a lot more time than you would expect them to, even when they're getting paid, and see this through. So I wanted to tell a little story that illustrates that, and that has to do with this Lego figure. So wanted to go into how he came into being and why he's here and what he represents here. So 4 years ago, I was at this conference and talking to another volunteer who was working on her PhD at USC, and she was talking about some issues that she was having trying to resolve a series of problems related to her PhD, and we got into discussing methods that she could use to go and approach them. And as we looked at it, I pointed out that some of the aspects of what she was trying to do, I was actually very, very familiar with and could help her out with, and started collaborating on that work. And what originally started being just this hallway conversation where we thought, spend a couple of minutes, give her a couple of pointers, and walk on, ended up being a collaboration that lasted many months, had a lot of code zipping back and forth between the East and the West Coast as we actually got this done. And she did an amazing PhD, got her PhD with honors, and it was, we were all very, very happy to see this. And Pat, so the one on the left there, who is the person who actually did this, was looking to say thank you in a specific way, just to see, what could she do, and realized that I kind of posted lots of stuff about Lego bricks on my Facebook page all the time. And it just so happens that Scott, her husband, the person on the right there, is a modeler in a gaming company, and they just happen to have a 3D printer in their garage, as one does. So they designed this little fella and 3D printed it, and then presented it to me at Siggraph 3 years ago. And after that, I couldn't walk 10 feet down the halls without somebody stopping me going, "Oh my God, that's so cool. Can I get my picture taken with him?" And ever since, I've been taking pictures with him. And if you don't already have yours, I would invite you to step forward at some point, stop me in the halls. We will take your picture. I have all the awardees right now, so we're well along to getting the rest of this room done. And just so you know, there's already over 5,000 pictures on his Facebook page. Okay? And we just crossed the 5,000 mark today. So that was actually pretty interesting. And that's just to give you a sense of why one wants to give to Siggraph, because this is what Siggraph is all about. It's all about giving your time, being passionate about what you do, and helping others. And I wanted to give a couple of other examples of this. So one of the key places that I've been focusing on has been chapters. So I've been a chapter member. I started out volunteering when the chair of my local chapter in Paris, where I lived in 1985, called for somebody to help them stuff envelopes. This was like way before we actually had email lists and all the rest, and we would actually send out notifications to our members, stuffing envelopes and doing things that I'm very happy we're no longer doing. So I raised my hand and said, yeah, I can do that. I'll volunteer. And then, 6 years later, I actually got elected chair of that chapter, then was promoted to go and become director for chapters, and then director for chapters for ACM, and well, the rest is history. That was quite a while ago, and has been going on for quite a long time. The interesting thing about chapters is that chapters extend what you see here at the conference every year. Throughout the year, you have local events that are happening, typically on a monthly basis, where you can network with other people who are interested in computer graphics and interactive techniques. And it's something that I've strongly believed in from the very beginning of my participation in Siggraph, because that's how I discovered Siggraph and started participating in it, and saw the potential for actually growing out a worldwide network of chapters so that we could spread the knowledge and spread the enthusiasm about graphics through this type of activities. Now, I chose this picture to illustrate it. So you see the guy all the way in the back with the green polo shirt? That's my son. He is the chair of the Toronto chapter and was giving a presentation at the chapters meeting on Saturday. And this is the third generation of the Chenet family, who is actually leading a significant role in the Siggraph family here. Another thing that I've been really, really passionate about at Siggraph, and I mentioned this earlier during the keynote session, was internationalization. When I started out as a Siggraph member, again in the mid-'80s, the running joke was that the A in ACM stood for American, especially when you were in Paris and trying to get papers accepted at Siggraph and trying to do all sorts of activities and realizing that everybody you were dealing with was from North America and that there was no representation or very little representation from outside of North America at the time. So at that point, I decided the only way we could fix that was to get significant people, and in my case, this was from France, and you'll notice that there is a significant representation of Frenchmen here at this award ceremony, which is pretty interesting to see. Now, we decided we might want to actually change the language officially to French, but yeah, maybe add a little bit of Portuguese too, just to go and take all this into account and see, where we would need to be. So going back to that, what I was looking to do is to see how we could change what Siggraph is to make it a truly international organization. And so pushed to get key people that I knew from outside of North America to put their names forward at every instance when an election was happening, to say, we need to be having a better representation in the organization. We need to be volunteering, becoming parts of the committee. And the nice thing to see is 30 years after I started doing this, and I wasn't the only one doing it, there was quite a lot of volunteers coming from outside of North America who pushed for this. We are an international organization. When you look at our structure, you see key volunteers within the organization come from all over the world. And if you looked at the fast forward session last night, it was interesting to me to see where people were coming from, how much diversity was in international diversity in terms of what I was seeing. We still have a long ways to go in terms of how many women were up on stage, but this is one thing where I've seen the organization change dramatically in a fairly short period of time, and that makes me excited about where Siggraph is going. But still more work to do. It's not over yet, but plenty of things to do. The other place I look at and that gets me excited and where I like to participate a lot is with our younger generations and trying to go and identify who are the leaders for the future in Siggraph. And when I look at the places where we actually groom our leaders, so one is the chapters program, but the other is here through the student volunteers program. And student volunteers come in, and if you look at who our current leaders are in the Siggraph organization, many of the chairs of the standing committee started out as student volunteers. And then once they graduate, once they move on, continue working with the organization, volunteering within other committees, taking on roles where they can do more and more, and then little by little learning the ropes and progressing throughout. This is something that I think is very, very important for the organization, that we continue supporting this. And I've been putting a lot of effort myself into helping the students move on in their careers, especially in their volunteer careers here, learn how to network, learn how to go and build on the relationships that they start up here at the conference and move on to bigger and better things. Now, this picture was actually taken in Kobe at Siggraph Asia this year, and I wanted to go and show that as a sort of an example of international student volunteers. And the key thing is, again, here, now, what was very funny was this picture was actually taken the night before last, where I was at a committee dinner, walked out into the hallway of the Annabella Hotel where we were having the dinner, and lo and behold, there were the key student volunteer team leaders hanging out there. Why? Because that's the hotel that they're actually staying at. So decided to take a group picture with them and use that as my example. And you will notice that my Lego guy is right there in the middle with them. They seem to like him quite a bit with the student volunteers. But these student volunteers, again, these team leaders who have shown initiative, who've shown a capacity to lead, are on their first steps to moving up within the organization. And it's great to see this type of structure built into what we do so that we provide the means for the kids who are so excited about what's going on here, that we give them the means to learn how to do more and incite them to come back and do ever more. Okay? So another example there is, as I was talking to these team leaders, one thing that really struck me was to see how much cooperation takes place amongst volunteers at Siggraph. So each team leader was coming up and posing, so that there's about 50 more pictures that I'm not going to show you here, but I just chose these 4 because of what they actually represented for me in terms of what happens at the volunteer level. Is the young lady there all the others had gone before her and had come up with very creative things that they were doing. She gets to the point where she's the last to go. I'm going to take a picture, and I've asked them all to do something creative, and she goes, like, everything I wanted to do has already been done by somebody else. Like, I'm not quite sure what to do. So the rest of the team started suggesting things that she might want to do, and one of them said, why don't you do a forced perspective? And she goes, yeah, I'll do that, but she couldn't do it all by herself. So one of the other team leaders said, I'll help you do that. I'll take the picture while you pose, and then we'll go and do this. And so I took pictures while they were working on it, and just thought it was amazing to go and see that happen, because you see that happen in all the committees throughout Siggraph, and that's what really excites me about our organization, how vibrant it is and why it works well. So I'll end on one last message that I'd like to go and share with you, and this is taking up something that Jeff mentioned during his talk at the keynote session, is to talk about elections. For Siggraph to be successful, we need to have good representatives and a high turnout in votes. Our nominations process works well. We actually do get very good candidates coming up through the ranks in the organization. What concerns me the most is to see the lack of participation from our members when it comes to voting. So we thought long and hard with the rest of the key people who have been working at the organization for a long time to see how could we make this even easier. So there's one message that you're going to be bombarded with throughout this week, is that we want you to vote. And we want to make it easy for you to vote. So what we've done is we've moved the deadline for the votes that used to be somewhere at the end of May, mid-June, way out until after the conference. And why are we doing this? Because we want you to vote while you're at the conference. All the candidate statements are up online right now. We have a session Thursday at noon where you can meet the candidates. You can ask them questions, and I would encourage you to go. Understand who's running this organization, who is proposing to run this organization, and see what they stand for before you vote, but mostly vote. Okay? Thank you. And Sue, I will turn it over to you. Okay. No, I'm just taking my stuff off. Yours should be.
Thank you for your patience. I'm now going to show you a unique video that Stina, who got the Distinguished Arts Award, has actually made especially for this occasion when unfortunately she can't be here. Just hold on a minute and I'll bring it up. Sorry.
It is a very great honor for me to get an award from Siggraph, because Siggraph might be the first institution ever to appreciate what we people were doing, we experimental video artists. And we found Siggraph sometime in the 70s through our Chicago colleague, Tonti Fante, Phil Morton, and Dan Sandin. And they would always accept our contribution to the show. And we had an opportunity to look at everybody else. And we went to several of them, Chicago and Las Vegas, San Francisco, so on. So I want to show first my first love of the signal, the electronic signal, the video signal, and that is how I combined it with my violin playing. This video was done in the 70s, and in the 80s there started to be a lot of digital video, and I was so lucky to get from the hardware making to the software making, and everybody was against digital as an inferior medium to analog, but I loved it. I just thought that you could address the frame, address a point inside the frame, instead of having to always address the whole frame. And that is like where this work is from. I regret that I couldn't come and be here, but what else can I do for you? I can always dance. advantages of digital is the shaping of the frame, how you can stretch it and squeeze it and change it. And since the analog image is small and very confined to 4:3, I wanted to fill a frame like what's called 916. So I just reshaped the frame until it was 3 times the image, and it puts for me a whole different kind of philosophy of images and what they can be. It's more like a painter, because painter starts with a canvas that is the shape he wants, and we image makers in film and video and digital, CAFE or whatever, we get the frame handed to us before we even start. Thank you very much for taking the time. Bye-bye.
So I think you got a unique glimpse of an early pioneer of digital art. Currently making images and things for you and dancing, I think it was a privilege to see it. And I know she kept sending me emails about, oh, it's such a lot of work, and then she said, but I'm actually really enjoying it. And I think I'm just like coders and just like artistic creativity, sometimes it's that kind of masochism that you have to go through, but in the end, that's why you do it, and that's why it makes it so great. So thank you very much.